Okay, perfect. We have the house music turned down. We have a few people that just arrived, so they're just kind of moseying their way on down here. So, since you guys are on time, we thank you very much for coming. I also see face coverings out here, so I really want to thank you guys for doing that. It means a lot to us. It's kind of a new way of doing things up here, and we're still getting used to it. Thank you guys for bringing your own chairs as well and making the reservation. Excellent. And let's see, so tonight's program, Kevin, over here. Kevin is one of the most interesting people you guys are ever going to get to meet besides Lonnie, who does every first Saturday of the month. Kevin has one of the most interesting jobs. He's the planetary manager. So if you guys do have any questions that are unrelated to this presentation, but maybe something about science or space, Kevin is definitely a good reference point. Come on down, folks. Okay. Well, since you guys are here, we're going to get the program started with Kevin tonight. Everybody else, we're going to kind of get them to come in here and be kind of quiet. After the program, Kim's going to talk to you about a couple things. If you guys have questions about the program as well, she's going to have you guys ask them towards the end. She's also going to let you know about this lovely sales desk inside that we do ask that only one person at a time enter unless you guys do have children. And last but not least, if you didn't notice on your way in tonight, you did not pay to enter our program. Everything we do up here at NJAG, we like to keep free. UACNJ is very proud that we do receive donations. So if you folks are in a position where you can donate, we ask that you use our jug over here. In addition to that, we also have it available online at uacnj.org, and scroll right down on that home page. You'll see on the bottom left side, you have a couple options to do donations there as well. And if by some chance you are not in a position to donate, we still love you, and we're so happy that you joined us. So make sure you guys keep making those reservations. And with that being said, I'm going to turn it over to Kevin tonight.
Okay, great. Well, thank you for that introduction, Matt. Tonight we're going to take a little voyage here to the red planet. We have a beautiful night here at NJAG. Looks like we're going to get some good stargazing in after the program. And so we're going to talk a little bit about a NASA mission that's taking place right now, and that's the Mars 2020 mission, which features a rover, a brand new rover called Perseverance. And so we're going to talk about this particular mission. We're going to talk about what's going to be happening once the spacecraft reaches Mars, and we'll talk about why this mission is happening now. Before we begin with the mission, I thought we'd review a few basic facts about the planet Mars. A lot of people, it's a pretty popular planet, and so a lot of people know about Mars. But let's review a few of the interesting facts, and we'll start with the size of Mars. Mars is about half the size of the Earth, and so it's a fairly small planet. It's half the size of Earth, but about twice the size of the Moon. So it's about 4,200 miles across. Oddly enough, the size, when you think of the size of the Earth and Mars, of course, remember that the Earth is covered, quite a lot of it is covered by water. And so there's a certain, the land masses on the Earth have a certain area. Well, it turns out the area of Mars is about the same as Earth, because the surface of the Earth is covered by water, but they're in terms of area, land area, they're about the same. In terms of mass, though, even though Mars is half the size of Earth, it's only 1/10 of the mass, and so it's a pretty lightweight planet. And that means that the surface gravity of Mars is really quite low. It's about half, or about 40% of what the surface gravity that we're experiencing right now here on the surface of the Earth. So a great weight loss program. If you have something here on Earth that weighs 100 pounds, well, on Mars it only weighs 38 pounds. So that's a pretty good weight loss program. Of course, Mars does have 2 small moons. The inner solar system does not have much in the way of moons. Earth has one, Mercury and Venus have none. But Mars has captured 2 rocks from the asteroid belt. These are not original to Mars, and very likely they've been captured over billions of years. And so you've got two asteroids orbiting around the planet, and they're really quite small, as you can see in this particular slide. Deimos is about 8 miles wide, and you've got Phobos about 14. The names of these moons, Phobos and Deimos, anybody know what those mean? Fear and panic. It seems kind of a downer, but remember that Mars is, what is Mars named after? Roman god of war, right? And so what accompanies war? Fear and panic. And so it's kind of appropriate. A little dark, but perhaps appropriate. So let's talk about timing. The planet, of course, is rotating just like the Earth is, and their days are pretty similar. Day on Earth, of course, 24 hours. But the rotation of Mars is a little bit slower, and so a day is 24 hours and 40 minutes, so a slightly longer day there on Mars. And the Martian day, by the way, is called Sol, after the sun. Remember, the sun does actually have a name. It's called Sol, the Roman god of the sun, and you see that in words like, we don't use it very often, but you see it in words like solar power, or solar system. So that's a Sol, and sometimes you'll see that mentioned in NASA press releases and story articles and things like that, and that's what they're referring to, one Martian day. So that's a day. Mars, of course, is the 4th planet from the sun. As many people know, the Earth is about 93 million miles away from the sun on average, but Mars is 142 million miles away from the sun. And so what does that mean for its year? Remember, a year is one revolution around the sun, one orbit around the sun. And so that means that the year on Mars is almost twice as long as an Earth year. So it's traveling more slowly, and its orbit got a bigger orbit, it's traveling more slowly, and so its year is longer. So what does that mean for its seasons? We're going to talk about that in a moment. Let's look at the temperature. Because Mars is further away from the sun, it's actually a fairly cold planet. Sometimes people get a little freaked out by that, especially young kids look at Mars and they see the red color of Mars and they think red is hot, so therefore Mars is hot. But of course it's further away from the sun, almost twice as far away, and so it's a fairly cold planet. And as you can see in this chart here, the low temperatures, the lowest temperatures that you would experience on Mars, which let's say during the winter time at one of the poles, you can sometimes get down to almost 300 degrees below zero. On a hot day, on the hottest day of the year at the equator during the summer, you might get up to 70 to 86 degrees Fahrenheit, and that's about it. That's the hottest day you'll experience. So most of the time, the temperature's pretty cool on Mars compared to the Earth. So it's a fairly cold planet. And those seasons, getting back to the seasons, as it's orbiting around the sun, and that slowly tilted a little bit more, 25 degrees. So it has similar seasons, but its year is longer, so how long are those seasons? They're twice as long. The seasons are twice as long as they are on Earth. The structure of Mars. Mars is quite a similar planet. It's a rocky planet. And so it may have an iron core, a solid iron core at the center, but we're not really exactly sure of that. There's a lot unknown about the interior. We know lots about the surface. We've got lots of spacecraft, and we've landed lots of spacecraft on the surface, so we know a fair amount about the surface, but there's still quite a lot unknown about the interior. And so we do have speaking of spacecraft, we do have a lander called InSight, which has been on Mars for a while now, and it has a seismograph on board. And so just like here on Earth, we can use earthquakes, or in that case, Marsquakes, to probe the interior of Mars and figure out, does it have a solid core like the Earth does? How big is it? And that sort of thing. And so hopefully, as time goes on, we'll be able to get that information from the InSight mission. So that's ongoing right now. The atmosphere. Mars, of course, does have an atmosphere, but it is really quite thin. It's 1/100th of the density of the atmosphere of Earth, and so it's a very thin atmosphere. Earth's atmosphere, of course, is mostly nitrogen, 78% nitrogen, 21% oxygen, and 1% of other stuff. For Mars, it's 96% carbon dioxide, 2% of argon, 2% nitrogen, and other stuff. And so the atmosphere is quite different, certainly not breathable in the conventional sense. And so if you're going to walk around on the surface of Mars, you definitely need a spacesuit. If I remember correctly, if you think about it, 1/100th of the atmosphere is kind of like being at about 30,000 feet here on Earth in an airplane. That's how thin the atmosphere is. So you've got two planets, and they're quite different. The Earth is very temperate, has a mild climate, it's got lots of liquid water on the surface. Mars, on the other hand, is a cold, dry desert world. Yet, Mars is the most Earth-like planet that we know of in our solar system. And so that's why we're so interested in it. We've been interested in Mars for a very long time, and we've been wondering, whether or not there is life there now. Has there been life there in the past? And so that's what this mission is mostly about, which we'll talk about. But why now? Why did we launch a spacecraft this summer towards Mars? Well, we've got the opposition of Mars coming up on October 13th. So next month we'll have opposition. And so what is opposition? We can see here in our slide, we've got the Earth, so the Sun, the Earth, and Mars kind of all lined up at opposition. So if you imagine here on Earth, you look at the Sun, what's the opposite of the Sun? Mars. And so that's why it's called opposition. They're in opposite parts of the sky. And so that's when Mars is closest to us. And so that's a good time to launch a spacecraft. You want a quick trip to Mars. You launch just before opposition and then land just after opposition, and that will give you a nice quick trip out to Mars. And so that's why we launched the Mars 2020 mission. This was the launch at Cape Canaveral. This was an Atlas V rocket that lifted off on July 30th from Launch Complex 41. And so a very successful launch there. And so off it goes. Right now it is headed towards Mars even as we speak. And so this rover is called Perseverance. NASA employees, they always find a way of finding little nicknames for the equipment that they work with. And so lately people have been calling it Percy as a nickname. Another interesting aspect of this mission you'll see in the foreground here. This is a little drone called Ingenuity, and we'll talk a little more about that later in the presentation. Well, how did they get those names? Well, just as they'd done with previous submissions, NASA had a naming contest. And so they had something like almost 30,000 students enter a contest to decide what the name of this rover was. And so the winner was Alex Mather, a young student from Virginia. And he thought it should be called Perseverance because in order to succeed, you have to persevere. Anna, Alabama, Vanessa Rupani from Alabama. She was just a high school student, and she came up with this Ingenuity name, and they like that too. And so they attached that name to the drone as well. So they both were winners in that particular contest. So how big are these rovers? This image gives you a pretty good size idea of the size of these things compared to a human being as well as some of the previous rovers. The first rover, successful rover on Mars was the Sojourner rover, named after Sojourner Truth, the abolitionist. And this was a very successful mission back in the late 90s, 1997. That was followed by two larger rovers, Spirit and Opportunity, which you can see off on the left-hand side here. And so these are the two solar-powered rovers that lasted from 2004 right up until 2018. The Opportunity rover operated until 2018. And then we also followed that up with Curiosity, and so the larger rover here, that's Curiosity, which is still operating, landed in 2011. or I think it was launched in 2011 and has been operating ever since on the surface. And Perseverance is very, very similar in design and very similar in size, except for it's a little bit heavier. Weighs about 2,200 pounds here on Earth. So that's a pretty big spacecraft. If you think of a Mini Cooper, next time you're in a parking lot, you see a Mini Cooper, that's about the size of this rover. So that's going to be heading towards Mars. Now, how do you land a big spacecraft like that? Some of the previous rovers used airbags, and that won't work for something that weighs over 2,000 pounds. So here's a little video of the previous, or the Curiosity, how they landed this, and Perseverance will use basically the same method.
When people look at it, it looks crazy. That's a very natural thing. Sometimes when we look at it, it looks crazy. It is the result of reasoned engineering thought, but it still looks crazy. From the top of the atmosphere down to the surface, it takes us 7 minutes. It takes 14 minutes or so for the signal from the spacecraft to make it to Earth. That's how far Mars is away from us. So when we first get word that we've touched the top of the atmosphere, the vehicle has been alive or dead on the surface for at least 7 minutes.
Entry, descent, and landing, also known as EDL, is referred to as the 7 minutes of terror, because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0 in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from the ground. If any one thing doesn't work just right, it's game over.
We slam into the atmosphere and develop so much aerodynamic drag. Our heat shield, it heats up and it glows like the surface of the sun. 1,600 degrees.
During entry, the vehicle is not only slowing down violently through the atmosphere, but also we are guiding it like an airplane to be able to land in a very narrow, constrained space. This is one of the biggest challenges that we're facing, and one that we had never attempted on Mars.
Mars is actually really hard to slow down because it has just enough atmosphere that you have to deal with it. Otherwise, it will destroy your spacecraft. On the other hand, it doesn't have enough atmosphere to finish the job. We're still going about 1,000 miles an hour. So at that point, we use a parachute.
The parachute is the largest and strongest supersonic parachute that we've ever built to date. It has to be able to withstand 65,000 pounds of force, even though the parachute itself only weighs about 100 pounds.
When it opens up that fast, it's a neck-snapping 9 Gs.
At that point, we have to get that heat shield off. It's like a big lens cap blocking our view of the ground to the radar. The radar has to take just the right altitude and velocity measurements at just the right time, or the rest of the landing sequence won't work.
This big, huge parachute that we've got, it'll only slow us down to about 200 miles an hour. And that's not slow enough to land. So we have no choice. We've got to cut it off and then come down in rockets. Once we turn those rocket motors on, if we don't do something, we're just going to smack right back into the parachute. So the first thing we do is make this really radical divert. We fly off to the side.
Diverting away from the parachute, killing our horizontal velocity and our vertical velocity, getting the rover moving straight up and down so it can look at the surface with its radar and see where we're going to land. And we head straight down to the bottom of a crater, right beside a 6-kilometer high mountain.
We can't get those rocket engines too close to the ground, because if we were to descend propulsively with our engines all the way to the ground, we would essentially create this massive dust cloud. That dust cloud could then go and land on the rover. It could damage mechanisms, and it could damage instruments. So the way we solve that problem is by using the sky crane.
20 meters above the surface, we have to lower the rover below us on a tether that's 21 feet long, and then gently deposit on its wheels on the surface.
As the rover touches down and is now on the ground, the descent stage, it's in a collision course with the rover. We must cut the bridle immediately and fly the descent stage to a safe distance from the rover.
Okay, so that was the landing on August 12th, and I like how the engineer at the beginning says, this is crazy, and it really is. It's really a totally bonkers way of landing a spacecraft using parachutes, rockets, and a sky crane, dropping it down. So it's a really complicated and kind of nutty way of landing a spacecraft, but yet it works beautifully. And the system has been improved even more for this particular landing. This is where it's going to be landing on Mars, Jezero crater, about 28 miles wide, located near the equator, just north of the equator, near a very famous feature on Mars called Sirius Major. And this location actually was picked out for the Curiosity rover, but then ruled out because they thought it was too dangerous. And so they've redesigned the navigation system to improve the landing, and so they can attempt a more risky landing safely. Jezero, by the way, is a name for a town. It's a Slavic word meaning lake, which is very appropriate for this particular landing site, which we'll get into in a moment. But this is where the rover will land and start to explore. Some people have asked about this rover, like, well, why do we need another one? We've done quite a few rovers, and this is looks almost identical to the Curiosity rover. Why do we need another one? Well, the previous rovers focused mostly on geology. Perseverance, of course, will still look at rocks quite a lot as part of its mission, but its focus is a little bit more on life. We really would like to know whether or not there was life in the past, or is there life there now? And that's what this mission is all about. Now, why they picked this particular crater, this particular location, and well, what is this mission all about? Well, I've got another short video. This one's about 3 minutes long that really explains why they selected this site.
You know, Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second two missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
One, two, three. Oh, good. It's back on. Yeah. So one of the reasons, so that's a big reason why we're going to this site. It was full of water at one point a very long time ago. So excellent place to look for possibilities of life. So these are the instruments that the rover are going to be using during this mission. And I got to look at my notes here because NASA has a terrible habit of making up acronyms for everything, and some of them are really complicated. And the first one is particularly complicated. Probably the most prominent feature of the rover is the robotic arm, and at the end of that robotic arm, you've got a lot of sophisticated instruments there. And one of the most prominent ones is an instrument called Sherlock. And Sherlock stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. And I'm like, whoa, that's a mouthful. Raman, that's not the soup. That is an Indian physicist who discovered that you could, in this case using an ultraviolet laser, you could fire it at some material. You're putting energy into the molecules and you can make them vibrate, and that will help you understand what the material is made of. And so this is a spectroscope, a spectrometer. That's what the spectrometer does. You can figure out what the materials are made of. And it also has an imaging camera that is like a microscope, and so it's kind of like Sherlock Holmes with his magnifying glass, and so that's where the acronym comes from. We also have on the robotic arm something called Pixel, the planetary instrument for X-ray lithochemistry. And so again, this is an X-ray spectrometer that is very high resolution, be able to look at very fine details on some of these rocks. And so very powerful instruments at the end of that robotic arm. We also have MOXIE. The MOXIE experiment, which was really kind of a clever piece of equipment. MOXIE stands for Mars Oxygen in Situ, in other words, on-site resource utilization experiment. And basically what MOXIE does is it takes in carbon dioxide from the atmosphere. Remember we mentioned the atmosphere of Mars is mostly carbon dioxide. And so what is carbon dioxide made of? You've got CO2, right? You've got carbon and you got two oxygens. And so MOXIE's job is to peel off one of those oxygen atoms, and that leaves you with carbon monoxide and oxygen. And so the carbon dioxide, you don't need that, throw that away. But then you're left with oxygen, which is great because you can use that for astronauts. Astronauts can breathe it, and it's also part of rocket fuel, isn't it? So you can make rocket fuel and air for your astronauts on future missions with something like MOXIE if this is successful. So this is kind of a demonstration of what might be possible in the future. There's also MEDA, Mars Environment. Are we having battery? Are we losing battery maybe? Yep, okay, I'll just continue. Hopefully it won't turn off again. MEDA is basically a weather instrument, weather station on board that will take a look at the atmosphere and tell us what the weather and the wind and that sort of thing, what's happening there with the weather, the climate. Another really prominent instrument is in the mast, the masthead. Head of the rover, which contains two very important cameras, the Mast Cam Z and Super Cam. Mast Cam Z is basically the kind of eyes of the rover here. You can see two and gets stereoscopic images and panoramic images, and so very nice instrument, very similar to what's on the current Curiosity rover, but a little bit more sophisticated because you can zoom in on different details, and so very powerful imaging equipment on top of that masthead, which is about 7 feet up. We also have the Super Cam. Super Cam is a really cool thing. You know, we talk about in science fiction about going to other planets. What this does, it fires a laser, and I forget what the range is, maybe about 20 feet or so. If you see something interesting, you can fire the yeah, it's a bit of, why don't you give me the hand, you have the handheld microphone? We could use that. Technical problem here. Try that instead.
Does this one work? Okay.
Okay, thank you. So Super Cam is really kind of cool. You know, in science fiction we talk about shooting things up with laser, and that's what the Super Cam does. You've got a laser, shoots out and vaporizes the rock, and it can analyze the chemicals from a distance. It doesn't have to be on top of the rock that it's testing. So a really nice instrument, very powerful instrument that will be extensively used during this particular mission. And here's the Ingenuity, that little drone that is traveling on board. The drone is actually nestled underneath the rover for transport. And once it reaches Mars, it will drop the little drone onto the ground and then roll away, and then the drone can fly off. It's like a little mini helicopter. And it's really very small. It only weighs about 4 pounds. So this is really another type of experiment. It's another demonstration that this is possible. You know, we've never flown anything like this on another planet. And so this is the first time that we'll have powered flight on another world. So a really kind of fascinating little project. It's meant to operate for about a month. And during that time, it can take flights of about 1,000 feet. 1,000 feet in terms of distance. It can go up about 30 feet high above the ground. And the flights are very short. Instead of being a flyer, you can think of it as a hopper. Kind of hops across the surface of Mars and can take pictures along the way. It doesn't have any really other instruments on board. It's mostly just an imager and a demonstrator to show that this type of thing is really possible. The rotors spin about 2,400 RPM. The flights only last about 180 seconds. But in that 180 seconds, they're going 1,000 feet away from the rover. So a pretty exciting little experiment that'll be happening during this mission. Another very important experiment that's happening is RIMFAX, and I won't read you the acronym. Basically, it's a radar, a ground radar. They're going to be firing radar waves into the surface of Mars, and you think of it kind of like a sonogram. And so it'll be able to look at what's underneath the surface, look at the layers of rock underneath, look for layers of ice, and that sort of thing. So a very nice little instrument that'll be traveling aboard this particular mission. Another really exciting thing they're going to be doing that's kind of part A of a very interesting project is that, the current rovers that carry drills, you can drill into the rock but it kind of pulverizes the rock, and you can look at it, and that's fun, but and interesting. But this particular drill will drill down into the rock and will pull out a section of that rock, and you'll be left with a piece of marshy rock that's about the size and thickness of a piece of chalk. And that sample will be taken and put into a little tube, and then the tubes will be dropped onto the surface of Mars and left behind like little breadcrumbs along the route as the rover continues on its mission. And so you might wonder, well, why are they doing this? This seems like a rather strange thing. You take a sample and then throw it away on the ground. But there is method to the madness. At some future date, there will be a spacecraft that will pick these samples up. This is a sample return mission that NASA is working on with the European Space Agency. And so at some point, several years from now, this mission will land on the surface of Mars. And it will carry a rover, which they like to call a fetch rover, because it's going to fetch your sticks that you've left behind. And so the rover will roll off the lander, go out, find the little samples that have been left behind, pick them up, bring them back to the lander, load them into the lander, and then the lander will fire them back to Earth. And so we'll have actual samples of Martian rocks that we can bring into laboratories and study them up close, which we've never been able to really do before, except for a few meteorites that we've found here on Earth. But we can compare them to the actual Mars rock samples. And so that's what's happening on Mars, and we are fortunate because we are near opposition, that Mars is in the sky now. And so I'm not quite sure Mars is really high enough for us to see tonight, but very soon, as time goes on, it'll be rising higher and higher in the sky. And so right about now, Mars is visible around 11 o'clock. Between 10 and 11 o'clock is a good time to look, because it's rising up higher up into the eastern sky. So when it'll face east, well, how do you find it? Well, just look for something really bright, because right now Mars is going to be, at opposition is going to be about -2. And so it's going to be brighter than any other star in the sky. And so it's very easy to find. Just face east, or if you're looking late at night, the southeast, and you'll see a very bright, sort of pinkish orange point of light, and that's Mars. And so definitely a very nice time to look for Mars as it gets closer to us, so we'll have a nice view. And it's actually going to be probably a nicer view of Mars this year than it was last year, even though Mars was closer last year. Mars, when it's at its closest point, like it was not last year, 2 years ago, is very low in the southern sky, and so it kind of doesn't get very high in the sky. You don't get that great of a view, even though it's rather large. This is going to be higher, much higher up in the sky, and so we'll have a really nice view of Mars. It might be even better than we saw 2 years ago. And eventually, as time goes on, well, perhaps this all could lead to astronauts landing on the surface of Mars and doing some long-term exploration of Mars. And so that's what NASA's working towards, going back to the moon and perhaps going on to Mars. And so very fascinating projects that are happening regarding the red planet. And so when does it get there? The Mars landing for Perseverance is going to be February 18th. So coming up middle of February 2021. This landing is going to take place, and hopefully it'll be successful, and we'll go from there. We'll see what information it turns up as it continues through its mission. And so if you'd like to hear some more information about this particular mission, some of the details, if you'd like to get some more information about it, it's run by NASA's JPL laboratory, Jet Propulsion Laboratory, JPL in California, and you can go to the mars.nasa.gov website, and that gives you more information about this particular mission and other previous missions as well. If you'd like to hear a little bit more about Mars, I have a little shameless plug for you. At the Newark Museum, where I am planetarium manager, we have a little online program called Ask the Astronomer, which right now is taking place roughly monthly. Our next one is coming up at the end of October, October 27th at 12 noon, and we have a very special guest, Emily Lakdawala, who's from the Planetary Society, and she's a real expert on Mars rovers and Mars. She wrote a whole book about Mars rovers, and she's going to be our guest. And so she's going to give us a little presentation, not only on what Perseverance is doing, but that's not the only spacecraft. I talked about one spacecraft tonight. There's actually 2 others that are headed towards Mars, and she's going to talk about that. And so join us on October 27th. And so I hope you learned a little bit about the red planets and learned a little bit about this particular mission. And so I think we have a little bit of time for questions. So we'll take any questions you might have. And Kim is going to hand out the microphone here. And,
Hello?
Yeah. Oh, God. Oh, you want me to do? You want to swap?
All right. Now that we've swapped microphones and avoiding that horrible interference we all hate, I'm going to be going into the audience and asking any questions you guys have. So, anyone have any questions? Raise your hand. Bueller. Oh, there we got one.
I see one over there too. Go ahead.
So how long is the Perseverance supposed to be there?
Oh, well, actually when I was doing a little reading, I didn't even really bother looking at the currently planned mission timeline, because, the last mission that, Opportunity, as I mentioned, lasted for years and years and years. So, I mean, the battery power on board can last up to 14 years, And one thing that was really smart, and I forgot to mention it during the talk, one thing that they did, one change they made to the new rover is they improved the wheels. One little mistake they made with the Curiosity rover was that the surface of Mars, the landing area, turned out to be much harder than they thought. And so if you ever look at some pictures of the wheels of the Curiosity rover, they're completely shredded because the surface was so hard. It's such a harsh surface that it really tore up the wheels and shortened the life of the wheels. And so they made more robust wheels for the spacecraft. The battery will last for 14 years, and so I think the mission will last quite a long time.
That kind of answered my follow-up question. How do they service it if something goes wrong with the rover?
You don't. You're stuck. There's no AAA on Mars, So if you break down and you bust a tire, that's it. Game over. And that's what happened to Opportunity. And one of the other disadvantage we were at the last opposition of Mars 2 years ago is there was a massive dust storm. And so when we set up our telescopes here to look at Mars that summer, Mars was almost blank because there was so much dust in the atmosphere. All the features were hidden, and the atmosphere was so thick with dust. Both of those rovers were solar powered, and so the Opportunity rover shut down, and that is deadly for a spacecraft because the temperatures are so cold. The temperatures go way down, and that ruins the batteries and ruins the electronics and that sort of thing. And so Opportunity unfortunately went to sleep and never woke up again. And so you got to build your spacecraft very well. That's why it takes so long to build these spacecraft. Perseverance was under construction for 8 years before it launched, and so you got to make sure you're building your spacecraft very, very well. Test it very, very well. Test everything you can test before you launch, because that's it. Once it launches, you're stuck. Yes, question for you.
Hi.
Hi.
Should I hold it? Okay. I thought that I read that Mars was either retrograde now or going retrograde either later this month, but does that have any effect on our research there, and what does that mean?
Not really. I forget when it starts and stops retrograde for this thing, but that's perfectly normal. And basically what retrograde means is that Mars seems to be moving backwards in the sky. And you might wonder, well, why is that? It makes this kind of little loop in the sky. If you watch, if you look at a map of Mars near opposition, it does this little loop where it goes backwards for a little while and then goes forwards. And that's called the retrograde motion. And that is just simply us passing Mars. We're moving faster, we're closer to the sun. As we mentioned, the year on Mars is much longer, it's moving slower. And so like a racetrack, like cars on a racetrack, they're going around the racetrack and the Earth is passing Mars on the inside track. And as we zoom past Mars, it seems to be going backwards. Just like on a highway. You're driving down the highway, someone is driving down let's say the middle lane doing 60 miles an hour, and you go flying past at 85, hopefully the state trooper's not watching, you go flying past at 85 in the left-hand lane, well, even though he's moving forward at 60 miles an hour, he seems to be moving backwards as you pass him. And that's the same thing that happens with Mars. That's the retrograde motion.
Were there any other questions?
The landing is supposed to be 18th February, so how long does it take from Earth to get there? When it leave?
It's about 8 months, but you can calculate exactly how many days because I don't know what it is off the top of my head, but it launched on July 30th, lands on February 18th. It's over how many days that is, but it's roughly, if you launch at the right time, it's roughly in the area of 7 to 8 months, something like that.
Right. Yeah. I think I saw another question in the back here. Oh, apparently we already answered their question.
Oh, okay.
Any other ones?
Any other questions?
All right, let me just check the online audience, and they appear to be good too. So, as we end our presentation today, I want to thank you all for coming out. A couple reminders: we do have the porta potty off to my right, your left, as our facility. We do have one scope open tonight, Jeff? Oh, we do have 2 scopes open. Like we mentioned earlier, with COVID and everything, the constant sanitation between people looking through an eyepiece would actually destroy a lot of equipment. So instead we do what we have, instead of the eyepiece, we have a camera attached where the eyepiece would go, and we use a computer to project that image onto a screen for you all to view. I don't know what we're currently viewing, but that will be up. We want to thank Kevin for his wonderful presentation. And we do, like Matt mentioned at the beginning, we do have a small sales desk behind us. We are a nonprofit organization, so everything we do, we try and offer for free, but we do depend on donations from you guys to actually continue our existence. Every volunteer you see here is a volunteer. We don't get paid. I've tried. Treasurer says no. I thought I was paying you in chocolate chip cookies. Shh. But don't tell anyone else, as I say this to the online audience. That being said, when you are leaving, we do ask, please do use your headlights. Even though it does affect night vision, we'd much rather people be safe and not get run over. It hurts to get hit by a car, surprisingly. Don't ask me how we know. So do use your headlights when leaving. Do be careful. We don't expect people to be running around, but you never know. And again, thank you all for coming. Enjoy your night.